Algebra Word Problems, number 2A, writing expressions with one variable from a word problem. When we do word problems, we need to use a strategy. We read the problem, we underline or circle important words or numbers, we make a plan to solve the problem. Well, we can figure out which operation to use, add, subtract, multiply, or divide. How are we going to use the information? And we need to turn unknown amounts into variables and use letters that make sense. We can make a table or a diagram to decipher what we need to do, especially if it's a hard problem. Making a table or a diagram can really help. We write out our equation, we find the solution, and then we check to make sure we did it correctly by plugging in our answer. So, I'm going to do this several times to make sure everyone understands that this is a coefficient and that's a variable. See, the number next to the variable is called the coefficient, and that's a number that's standing all by itself, all alone, okay? So here's our first word problem that we're going to write an expression for. The length of a room is 5 feet longer than the width. Using W for width, write an algebraic expression for the length of the room. Well, the length of the room is 5 feet longer than the width. So whatever the width is, we need to add 5 to it because it's 5 feet longer, and then we'll have our length. So the length equals the width plus 5. Here's our width. We drew the room to help us figure this out in our head. We know the length is the width plus 5. So our expression becomes L for length equals W width plus 5. See? L equals W plus 5. That wasn't too hard, was it? Emma bought items costing X cents, Y cents, and Z cents. Show how much change she got from a $1 bill using an algebraic expression. Well, the first thing we need to do is not compare dollars to cents. We need to have the same measures here, so we need cents and cents, okay? So, we're going to turn the dollar into cents. So instead of a $1 bill, we now have 100 cents. Now, if she bought XYZ, we're going to add them together and then subtract that from the 100 cents. So think of it this way. What if it didn't say XYZ? What if it said 25 cents, 30 cents, and 15 cents? That she bought something for this amount, and how much did she get back from a dollar? Well, we would just add these three up and subtract it from the 100 to get our answer, wouldn't we? Well, that's exactly how we're going to write our expression. We've got our 100 cents, we're going to add up the X, Y, and Z, and we're going to subtract that from the 100 cents. So 100 minus X plus Y plus Z becomes our expression. I'm going to put this in parentheses because we don't want it to be confusing. We want everyone to know that we need to add this first and then subtract it from the 100, see? 3 lock washers cost X cents. Write an algebraic expression to show the cost of 1 washer. All right, well, 3 of them is the cost of X, all right? We only want 1. What would we do if 3 lock washers cost 90 cents? What would we do? Wouldn't we divide that 90 cents into 3 so we could figure out what 1 is? Well, that's exactly what we're going to do. We're going to have X over 3, X divided by 3. If X is the cost of 3 of them, we divide the X into 3 parts. We divide it by 3 to get the cost of 1 of them. And then we know what the cost of 1 is. See? All right. If 4 tires cost X dollars, write an algebraic expression for the cost of 5 tires. All right, so think about this. You could try plugging in a number like 100. If 4 tires cost $100, what would be the cost of 5 tires? Well, wouldn't you divide the 100 into 4 parts to see how much each part was, and then we could multiply it by 5? That's exactly what we're going to do. X is the cost of the 4 tires, so we're going to divide X into 4 parts, see? Then we're going to get a single unit price. Then we're going to multiply that by that unit price by 5. We could also say 5x divided by 4. But do you get what we're doing? We're finding the price of one of them by dividing x into 4 equal parts. Now we know what 1 costs. Now we can multiply that 1 by 5, and we'll know the cost of 5 of them. See? All right. We're going to keep plugging. We're going to keep figuring out how to write these algebraic expressions. You're going to become a pro. Everyone's going to be envious of you because you're going to be so good at this. I'll see you next video. Bye.